This video covers reducing balance depreciation, which is the third and final type of depreciation that we will cover in general maths. We're on pages 13 and 15 from the booklet for this. So again, I'll start off with an overview. Reducing balance depreciation, there's a different loss in value each year. And that is because the depreciation, instead of being calculated on the initial value, it's being calculated as a percentage of the previous year's value. So it'll depreciate 1 year, and the next year's depreciation is based on that previous year's value, and that continues on throughout the life of the depreciation. On the graph here, you can see, say we have a car again, and it's worth $40,000. You can see this one here is reducing in value every year. This one here is reducing to, say, $27,500 in the first year. You can see it's depreciated by a smaller amount the next year, a smaller amount the following, and so on. And that's resulting in a curved graph. And again, the reason why it's a smaller amount each year is because it takes the previous year's value of the car into account, or the whatever else it might be. It doesn't have to be a car. And then it calculates the depreciation based on that previous value. Because it's lowering all the time, that depreciation rate will be less every year. All right, so just remember, curved graph for this one, and it's also going to be your N will be about time, generally number of years for depreciation. So let's have a look at our rule. Now you might look at this and think it looks a little bit familiar, and that's because it is. It does look a lot like the compound interest rule. So a way of thinking about reducing balance depreciation is kind of like reduce compound interest loans and investments, but instead of a positive here, it's a negative because we're reducing value. So once you pop your values into here, you'll do it in a very similar way as what you do in the compound interest section. When you solve what's in this bracket here, you will be getting a number that is less than 1. It'll always be a 0 point something value once you solve this bracket. Okay, and that's to show that it is losing value. It's always going to get, every year it's going to be worth less than it would have been the previous year. Okay, so again, these variables haven't changed. Vn is the value after n time periods. V0 is our principal, our initial buy price. R is your percentage depreciation per annum, and that's to the power of n, which again refers to the number of time periods or number of years generally for depreciation. All right, let's have a look at an example. So on page 13, a car is purchased for $32,000 and depreciated using a reducing balance rate of 8% per annum. Determine the rule for the value of the car after n years. So let's go through and find what we know. We know it's purchased for $32,000, so that is my V0. We're told the rate of depreciation per year is 8%, so my R is 8. Now that I have those, we can start forming the rule, because remember with a rule, you leave your Vn and your N as they are, and you are just subbing values into V0 and R. Let's write that out, and we'll go and sub those values in. So V0, 32,000, and R is 8. I always like a simplified version of this. So at this stage, you should grab your calculator, and just this section that's in the bracket, this 1 take 8 on 100, you should write that into your calculator and solve this, and then write it in that simplified way. So you'll get something that looks like this. Okay, so the value of the vehicle is $32,000 multiplied by 0.92 to the power of how many years down the track it is after purchase. Okay, and that's our rule. Now we're going to go ahead and use this rule then to solve questions. We can either solve what the value of the car is after n years, or we can solve a time in which a value is a certain amount. So part B, what is the value of the car after 5 years? What do you think we might do to the rule here? All right, then we want to know what the value is. So we're solving Vn, and we know that n is 5. Okay, so we've grabbed the rule, and we're subbing that 5 years into n. Okay, putting this into the calculator, you would have 32,000 multiplied by 0.92 to the power of 5. Make sure you remember it's to the power of and not multiplied. All right, that's giving us a value of the car of $21,090.61. Part C, the car is sold when it reaches a value of $8,500. Calculate how many years it will take to reach this value. So again, for this one, we are going to use our rule from before. So let's write that down. All right, here's my rule. I want you to take a moment to have a think about how we might use this rule to solve this question. We're told the value is $8,500. Which spot do you think that's going to go into? My V or my N? It's going to go into the V. All right, so the value of $8,500 goes in here, and we are going to solve how many years it takes to reach this value, which is given by our N. All right, popping that in there, you will then grab your calculator, you will type in solve, and then write this equation, so it'll look something like that. And again, make sure you remember it's to the power of. All right, that's giving me a value of 15.8988, which I will round to 15.9 years. Okay, so the car would be 15.9 years old when it reaches that value. Example 2, a machine is purchased for $21,000 and depreciates by 12% per year using the reducing balance method. Determine the rule for the value of the car after n years. Again, let's go through and see what we've got. We're told it's purchased for $21,000, so that's my V0. It depreciates by a rate of 12% per year, so that is my little r. We're told that's the reducing balance method, which is this rule here. Okay, remember your rule, Vn stays as it is, N stays as it is, and these two just get subbed into V0 and R. Let's go and do that. All right, you might remember me saying before, what I want you guys to do at this stage here is evaluate what's in this bracket. So simplify that using your calculator. You'll go 1, take away 12 on 100 for that bracket and rewrite it. All right, for this one, that's giving me Vn equals 21,000 multiplied by 0.88 to the power of n. Okay, that's my rule written. The machine is written off when its value is $4,530. How old is the machine at this time? So again, we're going to use the rule. How would I use the rule to solve this question? All right, we're told its value. So again, that is our Vn. And we want to know what our n is at that time. So I'll write my rule. I'm going to sub that 4530 into the value. Okay, that leaves me with my unknown, which is my n. I'll grab my calculator and type that into solve. Okay, and again, remember it's to the power of. All right, this is giving me an n value of 11.998, which is going to round to 12 years. So the machine is written off when it's 12 years old. Example 3, a fridge is purchased and depreciates according to the following rule. Vn equals 8,500 multiplied by 0.85 to the power of n. Again, make some links to what we know here. So this here, when looking at the rule, that should tell you that this here is my V0. And this 0.85 refers to the evaluated version of what's in this bracket here. Okay, so we can't really give a name to this 0.85, but no, it's got something to do with the rate. It's not the rate, but it's been calculated using the rate. All right, so how much is the fridge purchased for? That will be my V0. Okay, so the fridge is purchased for $18,500. What is the percentage rate of depreciation? So again, we can see it's something to do with this here, but we would just say it's 0.85. What I'm going to do is I'm going to get the values that are in this bracket, so the 1 take R on 100, and let that part there equal 0.85, okay? Because I know that they've gotten this 0.85 by subbing some stuff into this bracket and then simplifying it. Okay, so I'm going to get the 0.85 and let it equal the part in the bracket. Okay, and then I'll be entering that into solve. And I know I keep saying enter it into solve. You should all know how to do that by now, but if not, how about I go and do it with you? Okay, so I'll just show you one more time how to do this. We're on math 1. I'll click solve. 0.85 equals 1 take away fraction x on 100, comma x, telling me to solve for x. Okay, that's giving me an x of 15, which is telling me, sorry, I'll just get back to the slide there, which is telling me that my interest rate is 15% per annum. Okay, I say interest rate, it's not interest rate, it's a depreciation rate rather. Okay, so the rate of depreciation is 15% per annum for this fridge. If the fridge has a scrap value of $2,240, after how many years is it written off? And you should be used to these style of questions by now. We have a rule up there here that we can use. Have a look at the rule again. Have a look at the information we've got in part C, and let's see how we can solve this. All right, we're told its value, and we want to know how many years it takes to get to that value. So these are very repetitive. Hopefully you get sick of them by the end of it and know them by heart. Okay, here is my rule. I'm going to sub this value into the value part and then solve n. So there's my rule. There's a value subbed in. And again, we'll go to solve and solve that. All right, so it's after 12.99 years that it's written off, or I could round that to 13 years. Righto, that's it for this section. Go and have a try at the questions in the booklet, and that's on page 14, questions 1 to 3.